इस लेक्चर में हम डिस्कस करेंगे व्हाई द मेजरमेंट ऑफ नॉन इलेक्ट्रिकल क्वांटिटीज आर नेसेसरी. इंट्रोडक्शंस. व्हाट आर द नॉन इलेक्ट्रिकल क्वांटिटीज? Definition. Non-electrical quantities are physical quantities like force, pressure, displacement, etc. that are not inherently electrical but need to be measured and monitored. Quantities that are mechanical, thermal, or physical in nature and do not inherently involve electrical signals. For example, temperature, displacement, pressure, time, and frequency. So, what is the importance? Real world parameters must be captured and converted into electrical signals for control, because we want to control the real world parameters, we want to monitor, we want to automate them. So, for doing so, we need to first convert those signals into the electrical signal so that we can process them. So that is why we need to measure the non-electrical quantities, all like temperature, displacement, pressure, time, and frequency. Why measure them electrically? Easier transmissions, you can transmit them easily. Recording, you can record them, you can process them, and integration with digital systems. And what are the key challenges? Converting physical quantities into measurable electrical signal. And what are the approaches that can use? Like you can use transducers to convert these signals into electrical signals. And what the transducer is? A device that converts one form of energy into another. So in measurement systems, convert physical, or you can say non-electrical quantities into an electrical signal. And there are active transducer and there are passive transducers. The active is generate output without external power like thermocouples, and this one require external power like RTDs, LVDTs. We will see all of them. First one is the temperature measurement. Why measure temperature? Critical in process like chemical reactions, food processing, engine control. And what are its units? You can measure either in degree, either in Fahrenheit, and either in Kelvin. And what are the common sensor types that you can use? The first one is the thermocouple, RTDs, thermistor, infrared sensors. First one is the thermocouples. Principle Seebeck effect. A voltage is generated at junctions of two different metals when there's a temperature difference. And what is basically types J, K, T, and E, varied based on the metal pairs. So what are the characteristics? Pros, there are some benefits like ruggeds. Why? Like use thermocouples, ruggeds हैं, inexpensive है, and you can use for a wide range of temperatures. But there are demerits भी हैं इनके, non-linear outputs है, and it requires reference junction compensation as it's said in the definitions at the junction of two different metals where there's a temperature difference. And what are the applications where you can use them? The first one is the furnaces, ovens, gas turbines. The other sensor is the resistance temperature detector, RTD's. Principle: resistance of metals like platinum increases with temperature. And what material is used? You can use typically platinum, PT 100. And what are the characteristics? High, accurate, stable, and repeatable. But what are the demerits? It's a slow response, and the other one is costly, like you have to pay more. The other one is the thermistor. Principle: resistance decreases or increases, like PTC or the NTC, rapidly with temperatures. And what are the characteristics? It's sensitive and inexpensive. But what are the demerits? It's non-linear and the limited range is there. Infrared temperature sensor, non-contact measurements, that is a very major benefit. Principle: detect infrared radiation emitted from the surface of object, like you can say black body radiations. What are the applications? Medical thermometers, industrial monitoring, fire detection systems, HVA systems. The other one is the linear variable differential transformer, LVDT. Working principle: a movable magnetic core changes mutual inductance between primary and secondary coil. Output voltage proportional to the displacement. And what are the pros? Highly accurate means highly in resolution, frictionless, long life, no contact. What are the demerits? Require AC excitations. And what are the applications where you can use them? It's the CNC machines, robotics, and structural testing. Potentiometers. Principle is the mechanical displacement moves a slider along a resistive elements. Output is the variable voltage, and what are the characteristics? Simple, inexpensive, but wear and tear, limited resolution. Optical encoders, incremental and absolute. And what is the working principle? Use a rotating disc with the coded pattern to generate pulses. And what are the applications? It's a CNC machine and robotics. The other one is the capacitive and inductive sensors. The capacitive, change in gap between plates, alter capacitance. Inductive, change in magnetic field due to the displacement alters inductance, used in non-contact measurements and harsh environments. The second unit is basically the pressure measurement introductions. Why measure pressure? Monitor fluid flow, mechanical force, air gap conditions. The type of pressure, absolute gauge, differential. Units is Pascal, bar, ATM, atmospheric or psi. Strain gauge based transducer. Principle, pressure deforms a diaphragm to which strain gauges are bound. Output resistance change measures deformation of diaphragms. What are the characteristics? Accurate, highly accuracy and stable, linear and sensitive to temperature. Piezoelectric sensor principle, certain material generate voltage under mechanical stress. So generate charge under pressure, excellent for dynamic charging pressure. And what are the pros? High frequency response, and what are the cons? Not suitable for the static pressure. Capacitive pressure sensor. Diaphragm movement changes capacitance between plates, but used in HVAC, barometric pressure sensor and consumer electronics. Manometer, use liquid column to measure pressure difference. And what are the types? U-tube, inclined and digital, but it's working like balanced pressure against a column of liquid. The benefits are simple but not suitable for remote sensing. No electronics is required. The disadvantage is the bulky and slow response. The other one is the Bourgeon tube, converts pressure into mechanical movements. Analog dial is commonly used in industry. And the other one is time measurements. Why time measurement is necessary? Synchronizations is required, so control sequences, data logging. And what are the devices that you can use for this? Quartz clock, atomic clocks, and digital timers. Quartz clock principle is the piezoelectric property of quartz. It's vibrate at a precise frequency, exactly electrically excited, and the frequency range is 32.768 kilohertz. Accuracy plus minus 20 ppm parts per million. Atomic clocks, working is the use microwave signal emitted absorbed by the atoms. Accuracy 1 second in millions of years. GPS and scientific research. Electronic timer and counter, use oscillators and digital counters to track time interval. The application is the embedded systems and event timing. Frequency measurement. The frequency measurement definition is the number of occurrences of a repeating event per unit time. So devices, frequency counters are there, oscilloscopes and tachometers. Frequency counters working principle is count number of pulses in a fixed time window. And what is the accuracy depends on time-based stability. And it is used in RF engineering and digital communication. Second one is the oscilloscopes. The purpose is visual display of waveforms, allows frequency measurements, function, measure time between wave crests and calculate frequency. Tachometers, function, measures rotational speed. Type, if it's a contact mechanical connection to shaft, non-contact optical laser based. Sensor signal conditionings, why it is need raw signals are often weak, noisy or non-linear. and why it's a process, how to process them. You can amplify them, you can use filtering, you can linearize them, you can convert them into digital conversions. What are the application across industries? If it is aerospace industry, you can see the pressure, acceleration and temperature. If it is automotive industry, you can see displacement, speed and temperature. If it is a medical, you can see time, pressure and temperature. If it is a manufacturing, position, speed, pressure, frequency. If it is environmental, then you can see the temperature, pressure and time. Like these are the parameters that you can use. Summary table, if these are the quantities like temperature, displacement, pressure, time, frequency, and what the sensor types are mostly used. For temperature, thermocouple, RTD, thermistors. For displacement, LVDT, encoder, potentiometer. For pressure, strain gauge, piezoelectric. For the time, quartz and atomic clocks. For the frequency counter and tachometer. But what are the principles? For the temperature, Seebeck effect. For the displacement, inductance, resistance, optics. For the pressure, deformation, piezoelectric effect. For the time, oscillation of quartz or atoms. For the frequency, pulse counting. And what are the common applications? You can see temperature, furnaces, thermometer, HVAC. And for the displacement, robotics, machine tools. And for pressure, medical industry automation. For time, GPS signals, clock, instrumentations. For frequency, RF system, motors, telecommunications. So accurate measurement of non-electrical quantities is crucial for monitoring and control in modern technology. Electrical conversion enables digitization, automation and remote monitoring. Ongoing advancement like MEMS sensors, IoT integrations are enhancing accuracy, miniaturization and connectivity.